Thank you, Brian. Thanks for giving me another opportunity to address this community. I was here a year ago, of course. Some of you may remember. And the paint's still quite wet on the Intel relationship here. A year ago, I showed up and talked about Wham Cloud, which was the company that a few of us had started in 2010. And it was started really in a reaction to what we saw going on with Lustre. Myself, I was an architect at the Lawrence Livermore National Laboratory working on the Blue Gene project, which is currently the #2 system. And we saw that Oracle had ended up with Lustre and the entire pool of talent, and that they weren't interested in our community, the HPC community. And lots of speculation as to why. My particular speculation is that HPC doesn't have the profit margins that databases do. And so we really found ourselves as a community in a position where a technology that many of us relied on quite deeply and cared about, open source, that sort of thing, had been taken away from us, or at least the company that ended up with it wasn't so interested. So in July of 2010, myself and Eric Barton, who is in Bristol in the UK, decided we would start Wham Cloud with the goal to preserve Lustre for the community. We really cared that it was open source. We really cared that it was hardware platform neutral. You can run it anywhere. And we wanted to preserve that. We didn't think a world with only proprietary file systems really made any sense. And so these are the introductory slides from my last year's presentation. I talked a lot about the community. The community has really grown up around Lustre in the last couple of years. It's amazing how many different players there are. There's two community groups, the EOFS in Europe and the OpenSFS in the US. And you can get Lustre from 20 or 30 different providers at this point. If you back up 3 years, you could get it kind of sort of from Oracle if you bought their hardware. So I'm really proud of being involved in helping bring Lustre back. I don't lay claim to having done it all myself. Definitely it was a team effort, multi-company effort. But I think we're in a very good spot right now. And so last year I showed up and said, here's the status. Shortly after that, Intel agreed with us that Lustre was a critical component, and also agreed with us that there's a huge opportunity for this technology outside of HPC. I'm an old HPC guy, and I read all the big data and cloud computing and all that, and it just looks like HPC to me. It's just different buzzwords. So if you can get your mindset in talking about big data and virtualization and so on, it's just HPC. This technology, the Lustre file system technology, is very applicable to those spaces. And as Wham Cloud, we were fielding calls from all sorts of big data people, and we were just too small to be able to capitalize on that. Things are changing now. So with the acquisition by Intel, I want to claim that we completed the journey of trying to save Lustre for the community. Lustre is now on completely stable ground. It's completely vendor neutral, despite the fact that Intel's involved. Intel does not have a dog in the storage play. Intel does not care that we support Power, AMD, and other architectures. We are a standalone business unit within Intel. So Intel and Lustre. Intel bought Wham Cloud to be Wham Cloud. The quote here on the bottom is my boss. They've made no changes to anything we do. We're the exact same group. We've grown by about 20%. We still provide multi-vendor Lustre development, so we do the lion's share of the development on the code, adding the features, that sort of thing. I've managed to capture the majority of the software developers that have been involved in the GPL tree over the past 10 years. Open source, everything we do is online. We've got URLs to our up-to-date testing scripts, everything that we're up to. My source of information, I can hand you a URL and you get the same information. So we're very transparent. Everything we do is wide open. One humorous story, when we were going through the acquisition with Intel, they asked me to guarantee that we would have a staff retention level of 60%, then 80%. And I kept laughing at them, not quite understanding that most of the time when a company is acquired, many of the people involved in the company leave because they don't like the change of control, the change of management, that sort of thing. Wham Cloud has lost one person We were about 60 people. We've lost one person. We're now about 70 people because we grew. We lost a project manager who got a really good career opportunity and moved on. And the parting was almost tearful. He didn't want to leave the group. The group is really tight. So I think the point there is that the group is really focused almost to a religious zealot status on what we do. It looks like Lustre today. I'll get into some of the technology as to why it looks like more than Lustre in the near future. An important point here is Intel supports all of our business, including Fast Forward, which is the project I want to talk about a little bit. Fast Forward is a US DOE project that Wham Cloud won as a small company, $8 million. The rules of engagement in the US are that if you're a small company, you get to retain the IP ownership of the contract. If you're a large company, you have to augment the contract with a 40% cost share. So we novated this contract over to Intel within a month of becoming Intel. Intel had to throw $5 million worth of value on the table to that contract, and they did that. In fact, they made it my decision. They came to me, all the decisions are mine. I run the whole business unit. I went to them and said, I need $5 million more, and they said, if you need it for this business unit, you can take it. So we're providing an uplift to the current government contract that wasn't there prior. And of course, we're a member of the European Open File Systems. There's a meeting next week in Munich that I'm headed to. And we also recently joined the OpenSFS, the North American group, at the board level, which is a $500,000 membership. Again, I went to Intel and said, please give me $500,000. And they said, if this is the right thing to do for the community, we'll let you do it, and gave it to me. So this is what we look like. This is a new division. My boss is Boyd Davis. I'm right here. What you'll notice is a whole bunch of other technologies here, cloud technologies and caching technologies and so on. It's really a software division within Intel, software that is for sale, that has a business model that includes bringing profit back to Intel. So this isn't a charity. This isn't Intel giving Lustre to the community. This is the Wham Cloud business unit continuing to operate as we were as a for-profit entity. So on to the code contributions. I want to read from the bottom up. This version 2.1 is the unreleased version from Oracle. Oracle stopped developing on that around December 2010, if I remember correctly. And in January of 2011, Wham Cloud came out and made the promise that we would do a major release every 6 months and a maintenance release, minor release, every quarter. So what you'll see is these are the lines of code, 30,000, 50,000, 90,000. This is how much code activity, new code that's going into the Lustre tree. So it's quite an active project at this point. The other thing to note is the number of groups contributing to it and the size, the percentage of those groups' code contributions growing. The large bar is my group at Wham Cloud and now at Intel. So we're carrying 80% of the weight in the recent releases, but that's down quite a bit from the 90% that we did there. The other thing to point out here, and I made a point of it last year, is we broke the mold with respect to copyright assignment. These versions of Lustre, the copyright is owned by the people who put the code in the tree. That means that there are 12 or 15 different groups owning the code, that no one entity can take that code and do anything with it without getting permission from everybody. I truly believe that this technology belongs to you guys, the community, and don't want to see that messed up again. Oh, if you care to take a look at any of this data, like I said, all of our data is real time. I just went to that URL to take a look at the real-time contributions.
So some companies are not really directly calling their version Lustre.
That's news to me. HP used to have a SFS, maybe. But I think
when you look closer, it is Lustre with sometimes some tweaks, which are specific. I mean, I remember Fujitsu has FEFS.
Right.
Exascale, blah, blah, blah.
And DDN has a hardware project called Exascaler, right?
I don't remember that. Yeah, sorry for that.
Yeah.
But so they you know, when someone comes out with a proprietary architecture like the K computer, yeah, and you know, Toro's architecture and all that kind of stuff.
But the Lustre software can't be proprietary because it's a GPL tree, right? So they're not claiming a proprietary.
So what you, so that's my point.
Right.
So you can take that Lustre as it is in the open Lustre.
Yes.
And customize it as you need it.
Absolutely. And we're actually involved with Fujitsu in a project to take the modifications they've made to Lustre and pull them back into the tree because they want to be part of the community again. So this is the current roadmap. What you'll notice at a macro level is we do feature releases on a 6-month cycle and maintenance releases on a quarterly cycle. And we've hit that pretty consistently over the past couple of years. So there's enough data there to show that we're actually doing the work. A little bit hard to read here, the features that are going in. I want to go through a couple of those. But 2.4 is the release that's just in the works right now. We shifted it by a couple months. We're hoping it comes out in the April timeframe. And notice that we plan on migrating 2.4 up into a maintenance release cycle. There are several features in 2.4 that the community's been asking us for quite a while, such as OSD restructuring. Today, Lustre sits on top of an ext file system. When that file system, that ext file system crashes, you have to do an FSCK. You can be down for an entire day. So what we've done is we've structured the object interface and put ZFS underneath Lustre for Lawrence Livermore. So on the big Sequoia machine that I mentioned earlier, the number 2 machine, they're running ZFS underneath Lustre. That is all available, again, publicly posted. There's a licensing compatibility there that needs to be worked out if anybody wants to build an appliance based on those two. But the technologies are provably working, and more customers are coming to express interest in using them in that combination. If you're a HPC center and you're a roll-it-your-own kind of center, you can just pick this up and run with it today. There's minor performance problems on the ZFS side. Livermore did the port to Linux. You know, it's your standard HPC project where people are working through to get the performance out of it. DNE phase 1, those of you who have been around Lustre for a long time, there was a clustered metadata project. Lustre today generally has 1 metadata server, and the performance was limited to, I believe, about 20,000 operations per second. Many people were running into that limit and feeling like the metadata performance of Lustre was subpar. So we did 2 projects. We did DNE, which allows you to take multiple metadata servers and carve up your namespace. Think of it that you can do a makedir on a second metadata server. So if you've got Bob, the guy who trashes your metadata server, you get him his own metadata server. You share all the object storage devices or targets, but Bob can have his own metadata server, or you can split your user base into 2. So this is a half step towards the real goal of clustered metadata server, where a single directory can span metadata servers. But it releases a lot of pressure and scales up. And specifically, it scales up a lot better because we went through the metadata code and did a multi-threading pass on it. And so we saw an order of magnitude speed improvement on the current metadata server. And I believe that is in 2.3, the SMP scaling project here. So we went up from 20,000 to the hundreds of thousands kind of operations per second, which is fine for most uses. Once you get up into the million cores like Blue Gene has, they want to have the multiple metadata servers. We did a file system checker, LFSCK. The big one that people care about here is HSM, and Jacques Charles is not here. If you were here last year, I pointed at Jacques Charles and said, what's up with HSM? Well, what's up with it is it's coming into the 2.4 release. The code has been checked in. We're going through debugging right now. Like I said, we should see something in April or May, hopefully. And if you're watching the talks, I think there's a talk by Grau Data here, who will be one of the first to market with a third-party HSM solution that works on Lustre. So we've planned out the near-term future. We've got the next couple of releases. They're obviously not as well planned out as what's in the hopper. 2.5 is going to be open for contributions here soon. What I want to talk about now is the Fast Forward project. And I hinted at this when I was here last year, but the Fast Forward project became real in about May of last year, and then we won the project in June with a start of July 1st. So think of this as the US jingled around in its pockets and found $70 million to kickstart some of the technologies for for Exascale. It really was, somebody laughed, but the US can jingle around in their pockets and find order $50, $70 million pretty easily. So they just kind of said, there's 3 technologies that we think we want to get started with here: CPU, memory, and I/O. And so WAM Cloud won the I/O project. It's led by 7 of the DOE labs, and it aims really to just get us thinking about the big R, little d process of what are we going to do with I/O in the future. And I talked about it a little bit earlier. I talked about it last year, what the project was, but it's completely got wheels under it at this point, and I want to go into it a little bit earlier. So we won the file system component with partners, the HDF group. So I'll go into a little bit of the detail, but we're working with the HDF object schema, and we're doing an object-based storage model for this. We had EMC. You'll maybe heard the buzzwords burst buffer, and I'll point out a little bit about the architecture of burst buffers, and then Cray as a test partner. So in between these 2 lines, we became Intel, and as I said, we had to add $5 million worth of value to the project. So we brought back in 2 partners that were in our original proposal. One was Intel, a research group that does arbitrarily connected graph algorithms. Think of Facebook and all your friends, those sorts of things, or 3-letter agencies perhaps in the US. And DDN, who's been a very good WAM Cloud partner all along, doing a versioning object storage device. So today's programming models are bulk synchronous. If you take a look at the majority of the applications, you do compute, you hit a barrier, then you do I/O. When the trailing process comes in, you hit another barrier, and you start all over again. The white bars in here are wasted cycles, of course. You're just heating the room with your CPU at that point, waiting for the I/O to happen. As I called it at the Stanford Council, this is the overhead that you pay for because you have to do defensive I/O for checkpoint, or you have to write results out. What we want to move to, we being the I/O folks, to support the asynchronous programming models, is we want to remove the need for global barriers, global synchronization. We want to hand you an I/O interface that is not POSIX, that works on more like a database model with transactions and rollbacks and commit type activities. And we want to make it so that you can completely overlap all of your activities and still maintain a consistent view of your data no matter when you wrote it out by keeping track of things. So that's what we're headed for here. The way we do that is with transactions and something called epochs. If you think of these horizontal lines as compute and I/O, and the vertical lines as a version of your data. So you can have all of your processes write out data called version 1, and then they can, perhaps after the 100th loop in your program, decide now we're working on version 2 of the data. The file system will keep all of that consistent so that you can go backwards in time and read the data, or you can even look forward in time and block until the next version of your epoch is available to be a consistent state that you can read from. So all of this is intended to give you non-blocking protocols all the way through the stack. The other thing it does is it gives you guaranteed consistency at any time. Anything can crash, and just like a database rollback, we can roll you back to the last consistent epoch of your data. So think of checkpoints. You would use this to write your checkpoints and have the filing system take care of them such that when you crashed and came back, you would just say, what is the most recent epoch of my checkpoints, and you'd be able to recover from that and keep going. We're doing that for all of your data, though. So it's a versioning system. And then you will have the opportunity as the application programmer, you have the opportunity to decide what to do with your old epochs. Think of a copy on write file system where you can keep all of your history, or at the top of every hour you can cull 24 hours and older, whatever you want to do with it. So we're giving you all the capabilities here. Yeah. The limit? No. It's bound by the space that you have in your filing system. You run out of space. There's no limit built into the code. So this is the architecture that we're envisioning. I happen to be a fan of a torus type interconnect, having worked on BlueGene for a while. So this is your big cluster, your Cray, your IBM, whatever you have here. And even today, the Cray system and the IBM BlueGene will have I/O nodes. What we're doing is we're attaching NVRAM to your I/O nodes. And what our performance targets here are 200 terabytes a second. So what we're trying to build is a filing system that at the edge of your high-performance network can absorb 200 terabytes a second worth of I/O. And it will gang up smaller I/Os, so you will no longer need to care about running 1 megabyte chunks. You can write 1 kilobyte chunks or half kilobyte chunks and still get the majority of that performance. In the research project, we're using the PLFS project out of Los Alamos, I guess it is. And what that does is it allows us to aggregate all of the smaller writes into larger chunk sizes so that by the time we're streaming to Lustre, we're streaming in big, meaty block chunks so that we can get to the peak performance of the Lustre file system, which the current goal for Exascale is 20 terabytes per second. If you've paid attention to Lustre, you'll realize that a couple years ago, Fujitsu announced a terabyte a second for their K machine, and the Blue Waters machine at NCSA just achieved 1.3 maybe. So we're looking for about a factor of 20 performance increase in the filing system. And of course, this is backed by rotating disk, and disk is not appreciably gaining in performance. So there's another block of NVRAM out here. So that's the basic architecture that we're looking towards. The goal really is to turn the global file system into a global object store for the users and manage the explosive growth that's coming our way. But we're also enabling some very interesting and flexible analysis capabilities. So if you take a look at your storage cluster here, your scientist is busy running his parallel job and storing his output to the file system. One of the things that we're experimenting with, these little red sandboxes on the storage architecture, is allowing the scientist to put code directly on the storage system. So imagine that the scientist just has a huge amount of data and they want to stride through the data in such a way that they throw away 90% of the data. We're giving them the opportunity to filter that data at the storage cluster versus ship it all over the network. So imagine a sandbox VM, for example, on the OSD that allows the user to, within limits, use some of the cycles there and filter some of the data down. So we think this is a very powerful concept, and it's in the research stage at this point. But all of this work is completely open. Like I said, everything we do, there's a URL that you can go look at the architecture plans, the acceptance of the milestones by the DOE. So I think this is incredibly exciting stuff. We're really looking forward to this. And of course, it leans a lot towards the big data buzzword compliant action with objects and function shipping to storage devices. What we envision in the end, in the Fast Forward project, is a filing system that preserves the POSIX namespace, so you can traverse a directory structure just the way you do today. Today, you've got POSIX striped files in Lustre, but soon you will have this HDF5 simulation data, so you can CD into a directory and do an LS, and sitting there will be an HDF5 glom of data, which will not react friendly to the Unix tools that expect a data file to be a stream of bytes. You have to use the middleware, Python middleware that the HDF group is coming up with, that will let you jump into that file and make sense of its metadata. And of course, in the future, what we'll see, is the MapReduce format is a very interesting area that we're starting to play with. So we're open API here and inviting other than HDF groups to come in with their object schemas and program to the DEOS API that we call it. And the last thing here is a few weeks ago, Intel announced the Intel distribution of Hadoop. And this is a peer group of mine under Boyd Davis, and they are selling Hadoop and have modified it in various areas to make it perform much better than it does just from Cloudera, for example. We have been doing a lot of work with Hadoop on Lustre, driven by analytics in HPC environments. So in all of the HPC data centers that I've been in the last while, we decided that rotating disk in the nodes did not make sense. We put it across the network in the Lustre file system. Hadoop comes along and wants to have a disk co-resident with your node, and the HPC data centers don't want to go back there because they know the failure modes are horrific. So what we've done is we've replaced HDFS with Lustre, and we can feed you data from the global file system at the network speeds as opposed to your local disk speeds, which can be greater if you're using the IB interconnection. So we can feed you disk in a global sense faster than you can get it from your local disk. So the map portion of this, you pull all the data into your cluster. The reduced portion, it's already back out in a global namespace. You don't have to do any of this shuffling and message passing that you would have to do in Hadoop. And the other thing we can do is we can size your compute separately from your data. Today, Hadoop, you size your job by the amount of disk that you need or the amount of compute you need. We can do a surface to volume here and give you a much better ratio and much more efficient use of that. Some of the tests we've run and talk about here is simply that you run the same Hadoop jobs in your HPC environment and you see tens of percentage points of speed up. So the HPC centers that we've been working with in the US are pretty excited by all this. What I think you'll find is that Intel, and this is the ad for Intel, I'm not really a marketing guy myself, but Intel is positioning itself to be at the intersection of open source and cloud computing and HPC. It's very interesting to be at Intel right now. There's a lot of opportunity and a lot of excitement going on. Intel is incredibly supportive of open source software. They are the #1 or #2 contributor to the kernel, depending on which year you metric it. And so there's a whole open source group that makes sure that cards are played above the table, and it's a wonderful place to be. I'm a huge fan of Lustre being open source and happy to be working with the Intel open source folks to continue down that path. This is the group we work with. To my knowledge, this was the first time they had gotten together. We are a completely distributed team, 70 people in 8 countries and more time zones than I can count. I had worked with people for 2 years before I finally met them at this gathering in Hillsborough last fall. Very tight group. And I'm probably about up on time. I'll take questions if anybody has them.